Ben, we're gonna miss the start of the game.
Oh, the darn distributor got wet. I had to walk the last 4 blocks. Here, hold this, will you? Yeah, we gotta let that dry out, and I guess we have to wait here until it stops raining, huh?
Well, you always said you wanted to learn how to program my computer.
You bet.
Why don't we start that while we're waiting?
Are you serious? Me program the computer? I will be able to solve highly complicated formulas, control millions of names, billions upon billions of pieces of data. I'll rule the universe. How do I turn it on?
Jeez.
Aha, it says it's ready. Okay, I'm gonna ask you an easy one. Come on, answer me.
Looks like we're gonna have to start at the beginning. First of all, whenever you type a line where you ask it or tell it anything, you have to press the Enter key. That's what the Enter key is for. When you punch it, your command is entered into the machine, and the machine can then try and figure out what you just told it.
Okay. What? Oh, it can't even answer a simple question like that. Even my watch can tell me what day this is.
Look, the machine doesn't understand English. It only understands a simple language called Basic that has a simple English-like vocabulary. But also the machine is pretty dumb.
Yeah.
If you wanted to tell you what day it is, you can store a calendar in its memory and then give it the precise instructions so that it can tell you what you want to know. The sequence of instructions you give the computer is called a program. So let's begin with a single instruction program. Statement number 10, print, quotation marks, hello, John. Quotation marks.
No, what's that number 10 at the beginning?
Each statement must be numbered, and the computer follows the instructions according to the sequence of numbers. When I type run and hit the Enter key, what do you think will happen?
Oh, it'll print, hello, John.
See? Now you're on your way. The statement print is a word the computer understands, and it prints whatever follows it in the quotation marks. Let's try this one. Statement number 10, let n equal 3. Statement number 20, print n. Now, what do you think will happen when I type run?
Well, wait a minute now. Does the word let tell the machine that n will equal 3?
Right.
But it says to print n, so I guess it'll print an n. No, wait. There aren't any quotation marks around the n, so does it print what n is equal to in the let statement?
Yep. It's value 3. If it's in quotes, it prints what's there. If there's no quotes, it prints what it is equal to. You're catching on fast. Now try this one. 10, let n string equal...
Well, hold it. Now, what's that string business? It looks like a $sign to me.
This $sign symbol has nothing to do with money. It tells the machine that what is going after the equal sign is going to be a string of letters, or words, rather than just numbers. In this case, the word John. Next, we put 20, print, end string. Now, if we run it, we get John. Here's another short program you should be able to figure out. Okay, here's another let statement telling the machine what n is. And here's that same old print statement. In this case, n is an equation. But when we run it, we get the answer to the equation, 4, not the equation itself. Following it all right?
Sure, no sweat.
I'm sorry. I forgot your great mental powers. One more easy one. This program's got 3 instructions. First, a let statement to give Q a value. Oh, and this means 10 divided by 2. Then we let P equal 3 times 5. The asterisk is what we use for multiplication, so we won't confuse the machine with the letter X. And finally, we want to print out Q, P, and whatever P divided by Q is. Then we run it. We get what Q is, what P is, and what P over Q is, in the same order we asked for them in the print statement.
I've got all that, no problem. But I gotta know more than this easy stuff if I'm gonna take over the solar system.
Okay. You asked for it. Let me show you a program that'll start you on your way. This three-statement program starts with something familiar, a print statement. So it will first type out what's in quotes here. It proceeds to this next instruction, input X, where the computer will stop until you input some value for X. When you input a number, it will then proceed to the next statement, which is a print instruction that prints out a group of words in quotation marks and a value for X.
Okay, let's run it. I want to see what happens.
There, you see? It printed what was in quotation marks in the first command, then stopped when it came to the next, and signals this by a question mark. Give me a number, John.
Well, how about lucky 7?
There, you see? Once you give it what it asks for, it resumes running the program. Remember, the last print statement in line 30 asked the computer to print the words you picked, and then the value of X. And here it is.
So once a program is rolling, it can ask me for data to complete the program. Well, that's pretty neat.
Mm-hmm. That's the way you interact with computers when you're doing things like playing games. The computer is programmed with a game program, and when you play it, you're just putting data into input statements, though you may not know it. You can use all sorts of devices to communicate with the computer, to give it data through input instructions. You can use a device called a light pen that can input data into a computer when you touch certain areas of its video screen. You can even input information by voice if you have a microphone connected to a personal computer.
La maison.
Well, now we're cooking. Let's see some more.
Okay, this will look familiar.
What's this? Go to 10. What's 10? Does it mean to go back to instruction 10?
Yeah. And what do you think will happen if we run this?
Well, the computer will print, hello, John, and then move to the next instruction, which will tell it to go back to 10 and print, hello, John, again and again and again. And it looks like it's running in circles.
Right, it's a loop. Let's see.
Hey, what's going on?
That's really the first time you've seen how powerful this machine is. Let's stop it. And let me type list. An instruction which will list the program. You can see that from this little 2-instruction program, the machine can keep printing indefinitely. Watch it run again.
Yeah, that's impressive. But how do you control it?
Well, you can do more than control it. You can make it work for you.
Yeah?
Mm-hmm. But first, let's look at this program I've just loaded from this cassette. This let X equals 4 lets us enter the number of loops we want the computer to make. Line 20 tells the computer to print titles labeled player and season average. Line 30 tells it to print dotted lines, which will appear under the titles.
Hey, can the computer jump from 30 to 110?
Sure, and that's to leave room to insert additional data later. You'll see in a minute. Now, in line 110, the program will create a new value for X by subtracting 1 from its previous value of 4. This will create a new value of X equal to 3. The machine continues to the next statement, line 120, where it makes a decision. If X equals 0, then go to line 140. Since X does not equal 0, the computer skips ahead to the next line, 130, which says go to line 30. There, it will be instructed to print the dotted lines again. The computer will then proceed on from there to line 110, and again reduces the value of X by 1, this time from 3 down to 2. Well, you can see that it will go around this loop 4 times until X finally does equal 0, and it finally can go to 140, which ends the program. What do you think will happen when we run it?
Well, it'll go around in circles, It's only printing out a dotted line each time, and it has an end, so... it prints out the dotted line 4 times. I guess you could change that number for X and print out as many lines as you wanted. Okay, now we can control it, but can it do anything useful?
Would I leave you in the dark? That's why I just entered another program from this cassette. Take a look.
Egad, it fills the whole screen.
Now, don't freak out. When I cover up the middle statements, you see the same first 3 statements, and below, the same last statements as before. Only now we've got some useful data in the middle of the loop to work on.
I wondered why we skipped those middle instruction numbers before. Hey, those are the guys on my intramural basketball team and their scores in the first couple of games.
These read and data statements allow us to put the data we want to work with within the program. The read instruction reads the name, end string, and the individual scores from the data statement. So end string would be J. Bennett. S1 would be 12, S2 would be 15, S3, 11, and so on. The computer then drops down to the next non-data instruction, line 90, which is a formula to compute each player's average. And then in line 100, prints out his name and average. After going through the loop X times, or 4 in this case, it will have computed and printed all the players' names and averages.
Wow, so with these couple of instructions, let, print, read, data, if, go to, I can do all this?
Once the basic program is written, you can put more players and scores in later and keep track of hundreds if you wanted. I can even show you how to have the computer select the highest average, the most improved player, the most consistent player, and so on. With just these few instructions, and with 10 or 15 more, you can do just about anything.
Yeah?
I think the rain's stopped. Let's see if we can get your car started and catch the second half of the game.
Yeah, wait a minute. I got an idea.
Come on,
I
we
just want
already
to try
have the
something.
tickets. I've got your sector, King John.
Coming, my little computer queen.